how last time I showed those graphs up here and we did the Taylor polynomials. And I said, like, the higher the degree, the better it is. And if you take it out forever, it becomes literally perfect. So whenever it goes out forever, so infinity, we call it a power series. And what we're going to do today is represent functions as a power series. So we're going to take it out to infinity and it'll be actually perfect. So the series will actually equal the function, which I know that the problems can be annoying, but the concept is really kind of cool. Like you can make those, like the series go out forever and it's going to actually equal the function. That's neat. Now, the only ones we're going to do these for are geometric, because geometric has a specific pattern that we can follow. So you want to remember, and I wrote it on here for you, it's a over 1 minus r. Do we remember this? Or do we totally delete everything from the last unit?
No.
Okay, because we got to keep that. All right, so the first thing that you want to do is make sure that it's centered correctly. And this is going to involve a little bit of tedious algebra. And you're going to have to like watch your negative signs and all that fun stuff. Make sure it's centered correctly. If it's centered at 0, you would just have x. If it's centered at, for example, 5, you would have an x minus 5. Do you remember your left to right shifts with your functions? How it's kind of backwards? Okay. So if it's centered at 7, you would need an x minus 7. If it's centered at -2, you would have an x plus 2. Is this making sense? Okay. So you make sure it's centered correctly. Then you make sure that r is being subtracted because it's 1 minus r. So usually you can fix that just by dividing by a negative, and that'll flip that around. So make sure r is subtracted. And then the last thing is you need to make sure that there is a 1 right here. A can be whatever wacky number it comes out to, and usually a does end up being sort of weird, but this has to be a 1. A can be whatever it is, and r can be whatever it is, but this has to be a 1. So make sure that it is 1 minus r, like that has to be a 1. And so again, it's really just a lot of kind of tedious algebra to get through these. And I made the first one simple so that you could see what we're doing. I made it just follow the pattern. Do you see how this follows the pattern a over 1 minus r? And we're centered at c equals 0, so it would just be an x. So a is 1, just whatever's in the numerator there, and r is x. So I made that one just work. We didn't have to do anything to it. Again, I wanted the first one to be sort of simpler for you. And so you're going to write out your series, sigma n equals 0 to infinity. And it's this pattern, a times r to the n, a times r to the n. So it would be 1 times x to the n. And I'd like for you to write out at least the first 3 terms, and then you can put ... But just at least show me the first 3. So your first term is going to be 1, and then you just keep multiplying by x. So the next one would be x, and then what would the third one be? Be x squared, and then you'd have x to the third, x to the fourth, x to the fifth, forever and ever and ever and ever and ever. So that's what I'm looking for, is write it with the sigma notation and then show at least the first 3 terms. Okay. Again, I made that one just work out. The rest of them are going to be a little bit trickier. You're going to have to do some algebra. So this is the same thing, but this time I want it centered at c being -1. So here's what I always do. I'm going to take this 1 over 1 minus x, and I want to kind of mess with that. We're going to maneuver some things. So the first thing is you want to make sure it's centered correctly. That's step 1. So if I want this to be centered at -1, I'm going to need to have an x plus 1. And then we have a negative in front of that. But you need to maintain the integrity of the problem. So you're not allowed to just change stuff. So here's where you have to, like, it involves some thought. What number would go here so that these would be equivalent statements? And I would think about distributing this negative, like this would be a minus x, which we have right here, and then -1. But what number would need to go in this spot to ensure that it should still be a positive 1? Put 2. Because if you were to distribute this, and let me just show you on the board what that would look like. If you take this 2 minus x plus 1, if you distribute your negative, you get that. With me? Okay. And then 2 minus... Figure that out. we got it centered at the right place. Then you need to make sure that R is being subtracted. So do we have a subtraction here? Yes, we're good. Again, if it's not, you can fix it just by dividing by a negative. And then the last step is you need to make sure this is a 1. It's not. How could you turn a 2 into a 1? Like, what could we do to that? Yeah, make it, we're going to basically divide everything by 2. And you have to divide all 3 of these. So you have to divide everything by 2. So it'll be 1/2 on the top. I'm going to divide this by 2. 2 divided by 2 would be 1. That was the whole point. And then I'm going to divide this by 2 as well. Actually, let me put the parentheses around the whole thing. So you're dividing all 3 parts of it by 2. Now I realize that that looks awful, but we now have it in the correct format. What is A? A is a 1/2. And R is this part, x plus 1/2. Sometimes A and R end up being rather messy by the time you've like readjusted everything, but that's okay. They just come out to whatever they come out to. So we're going to write it with our sigma notation, and I want to do like at least the first 3 terms just to like generate the pattern a little bit. So it's A, which is a 1/2, and then R to the nth, which is this x plus 1/2. So our first term is A, so that's a 1/2. And then you just keep multiplying by this x plus 1/2. So that would give you x plus 1/4, good. And then you'd have x plus 1 squared, good, over what would go down here? 8, good. And I just want you to show me the first 3 just to show you can, get the pattern going. So this one, I'm going to take this off to the side. We're going to have to mess with it. So 4 over, now it says x plus 2. I'm going to write 2 plus x because you want that variable to come second. Centered at 0. So actually centering is fine. If it's centered at 0, that's going to just be an x. So that part's good. What was our second step? We have it centered correctly. Then we need to make sure R is subtracted. In this case, it's being added. You can fix that just by dividing everything by a -1, all 3 parts. So it's going to be -4 over -2 minus x. Basically just made the whole thing negative. And then lastly, you need to ensure that this is a 1. It doesn't matter what A and R come out to. They just come out to whatever they do. But I need for this to be a 1. So I'm going to divide all 3 parts by a -2. So what would that give us on the top? If I divide everything by a -2, just 2. And then this will be a 1. That's the whole point. And then minus x over -2. And so what is A and what is R? Now that we have it fixed. A is 2, and then this would be x over -2, or -1/2 x. You can put the negative out front. It really doesn't matter where the negative goes. And then we're going to write it with our sigma notation and then list out the first 3 terms. So how would the pattern go in here? Well, the A would come first, so we'll have 2. And then R to the nth. So this x over -2 goes right there. It's A times R to the n. Yes, I have 1 on the back where we are going to have to change it, but I'll explain why when we get there. Otherwise, no. And that's a really weird problem. But I still want to show it to you. But otherwise, no, it's going to be 0. That's the pattern. That's like almost sort of by definition. That's this. Let's try this one and then I'll give you a break. All right, first make sure it's centered correctly. And actually, let me take this off to the side. 5 over, I want the variable to come second. So I'm actually going to write this the other way around. I'm going to write it as -3 plus 2x. Or, oh, yeah, sorry, I got a question there and I forgot to write these out. Sorry, first three terms. What's the first one gonna be? We have 2. And then we're multiplying by a negative x over 2. So actually the next one would be just negative x. And then the next one would be x squared over 2. And those are going to alternate. So like the next one would be negative. I tend to always write a plus. You technically don't need this plus if you don't want to put it. You don't need to write plus and negative like that. Like it's going to alternate positive, negative, positive, negative. Okay, I'm sorry. Now the next problem. So I took this and wrote it off to the side. You want the variable to come second. So I wrote it as negative 3 plus 2x. First thing is you want to make sure it's centered correctly. So I'm going to rewrite all of this. What would I want to go in those parentheses to make it be centered at negative 3? Yeah, x plus 3. And the 2 being out there is fine. That it just got multiplied by a 2. Kind of like how this one was divided by a 2. That's fine. It just comes out to whatever it comes out to. But we have it centered correctly, so that's good. What was the next thing we had to worry about? Like, what do we have to fix next? We have it centered now. Yeah, r needs to be subtracted. It's not, it's being added. So how do we fix that? Yep, divide by a negative, multiply by a negative, however you want to think of that. It'll be negative 5 over 3 minus all of that. And then what's your last thing you have to worry about or adjust for? Or, oh, you know what though? I made a mistake. I did not maintain the integrity of the problem. This isn't going to be a 3. I'm sorry. We have to figure out what number goes there. I apologize. You can't just go around changing the problem, as nice as that would be. If you were to distribute this 2, you would get 2x plus 6, but I need for it to still be a negative 3. So what would I need to put there? If this is 2x plus 6, but I still want it to be a negative 3, it would have to be a negative 9, and then this will be a positive 9. I'm so sorry. Because you can't just change it. It has to still be the same. Even though we're maneuvering things around, it still has to be the same thing. And then we want that to be a 1. So how could we do that? Change this to a 1. Yep, divide everything by 9. So we'll have negative 5/9 over 1 minus 2/9 times all the rest of that. And again, that can turn out as messy as it turns out to be. This just has to be a 1. So what is A and what is R? What is our A value? Negative 5/9. And then R is the 2/9 x plus 3. So we're going to write our sigma. It'll be A times R to the nth. And then I just want us to like generate the first couple terms of the pattern. If we do 3 of them, that's good. The first one will be your negative 5/9. And then we want to keep multiplying by R. So we need to multiply by 2/9 x plus 3. So if you multiply this by 2/9, that would be negative 10 over 81, and then x plus 3. And then if we multiply by 2/9 again, that would be negative 20 over 729. Because 9 times 8 would be 72. And then a 9, 729. And then what? Good, x plus 3 squared. And I kind of ran out of room for the plus dot, 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 but it's going to go on forever and ever. So sometimes they end up looking really messy. It's really just a bunch of algebra. But we'll do like a 2-minute break and then we'll do the ones on the mat. All right, so same thing. We want to be centered at c equals 1. So first let's take this 1 over x off to the side. And we need for it to be centered at 1. So what would I need to have in the parentheses here? X minus 1. Now, I'm not going to mess it up this time or forget to do this step. I need to figure out what number goes out for, and I realize that's a plus. We're going to have to fix that as well. But it's because this is a positive X. I don't want to try and change too many things at once. I need to figure out what number goes there so that it'll still be a nothing plus X. So what would need to be there?
No, 1. Well, yeah.
Either 2 or 1. I think it'd be 1, right? Because 1 minus 1 will give you nothing. Okay, I didn't forget to do it that time. All right, so we got it centered at the right place. We have it centered at 1. Then we need for this to be subtraction. So I'm just going to divide everything by a negative. It'll be -1 over -1 minus X minus 1. Like everything is negative. So we have it centered correctly. We have this negative. The last thing is this needs to be a +1. And it's like, but wait, the way I would do that is to divide by a -1. It's going to sort of just turn everything back to what we had. It'll be 1 over 1. I'm going to leave this as minus because that's part of the pattern. So it has to be minus. And I'm going to write this as X minus 1 over -1. That's kind of how I had to do that to keep the negative where it needed to be. The problem just had a ton of negatives in it, which negatives are hard. So it's not an easy problem. There are ones all over the place. All right, so what are A and R? What is our A value? 1. And then R is this X minus 1 over -1. So we're going to write it with our sigma notation and then list out the first couple of terms. So it would be 1 times, actually, I'm not even going to write that 1 for A, times R to the N. Now, if you take this to the nth, do you see how the denominator would just be a -1 to the nth? You're coming with me there? So I'm going to write it like this instead so that we can see that it's an alternating series. I'm taking this to the nth power. I just sort of wrote the -1. And if you're like, wait, but it was in the denominator. 1 over 1 is 1, so it's fine, just the -1. But that makes it a little easier to see your terms, and they're going to alternate. All right, so if we start with A, our first term is 1. And then you keep multiplying by this. So the next term is going to be negative because it's going to be an alternating series. And that would be X minus 1. And then the next one's going to be plus what? X minus 1 squared. And then I won't make you write it, but the next one would be minus X minus 1 cubed. And then plus X minus 1 to the 4th, and so on and so forth. All right, now this one says find a power series for Ln of X centered at 1. We're going to actually use the one that we just did in order to do that. What connection can you make between these two? Yeah, so Ln of X, the one that we want to do, is the integral of the one that we just did. So the one that we want to do Ln. That's the integral or the antiderivative of this one that we just did. So we are just going to do the antiderivative of this thing, and that's our answer. And I think this is the one, if I'm remembering correctly. No, this can be, well, you know what, actually, I don't remember. Let me not leave that 0 for a second. I know one of these comes out weird and you can't put a 0 in and you have to start it at 1. I think it might be the next one, but actually, yeah, it's going to be the next one. We can keep this one at 0. So we're going to do the antiderivative of this. Now, the part that makes it alternating, like that -1 to the n is just the part that makes it alternating. We're not dealing with that. So we're going to do the antiderivative of this. So you would raise the power. So it'll be X minus 1 to the n plus 1. And then what do you do when you're doing an antiderivative? You raise that power and then divide by so it would be over n plus 1. It's weird because there's not an actual number there, but do you know how you get a lot of like 1/4 x to the 4th or 1/5 x to the 5th? It's just that it's an n plus 1 because we don't know what that number is. Is it like,
Yeah.
okay. And then I want us to list out the first couple. So if you plug in 0, it's going to end up being a positive term. -1 to the 0 would just be 1. So this part we can kind of ignore. And if you plug in 0 here, 0 plus 1 would just be 1 for both of those. So you actually just get x minus 1. And then your next term is going to be negative. And if you think about plugging in 1 for these, they're both going to turn out to be 2. 1 plus 1 would give you 2. So it'd be x minus 1 squared over 2. And then it's going to alternate. So what's the next one? Yeah, positive x minus 1 cubed over 3 plus ... Because I don't actually know how you would do ln of x. Like that, you can't turn that geometric in any way. So you kind of have to use the one you've got and just do an antiderivative. You can also do a derivative. So look at this, and don't look at this sigma because that just looks awful and it always throws everybody off. What connection do you make between these two?
What's the second? It's just good. It's the next step of the ball.
Wait, it's the next what?
Plus 1 of an alternating 2.
Well, but there's a squared in there. I kind of see what you're saying. Let me back up a step. You know how we said the connection between ln and 1 over x involved an antiderivative? What would be the connection between these two? Yeah, one is the derivative of the other. So the derivative of this one, was that a plus? X plus 1 equals this one. So that's the connection between them. The derivative of that one that we're given, that awful sigma thing, the derivative of that is going to give us the one that we want. So I know that that looks awful, but it's not really going to be too terrible. And I'll show you why we have to change this in a second. We're just going to do the derivative of this. And again, the alternating part is not doing anything. That's just literally the thing that makes it go positive, negative, positive, negative. That's all that is. We just need to take the derivative of x to the n. So what would that be? If we do a derivative of x to the n, good, n times x to the n minus 1. Good. Now here's why this can't be 0. If you plug in 0 for n, do you see like what kind of problems that would cause? First of all, the whole thing would be 0, but then this would be x to the -1. So you have to start it at 1 instead. And it's because you dropped that a degree that it just got like scooched over a bit. Anyway, that's the only time you'd have to start that at 1. If you try to plug in 0, this is just not going to work. So let's plug in 1. I think the whole thing would just be -1, wouldn't it? Because if you plug in 1, this part's going to be negative times 1. Anything to the 0 is 1. Yeah, so your first term would just be -1. And then the next one's going to be positive. Well, when you do -1 to the first, this piece, yeah, we're plugging in 1 instead of 0. If you plug in 0, it's just not going to work.
No.
Guys, this is probably like the hardest course offered at the school. The material's hard, all right? Not yell at each other, all right? So the next term is going to be positive. If we plug in 2, we'll get 2x, be 2x to the first. And then the next one's going to be negative. And if we plug in 3, we will get 3x squared. And then I won't make you write them, but what would the next one be? 4x to the third, and then minus 5x to the fourth. You okay over there? All right, last one. Find a second degree Maclaurin polynomial. This is kind of a review of what we did last time. What you want to do is rewrite this as e to the x times 1 over 1 minus x. It means the same thing. So e to the x we did last time. And do you remember how I said there were a couple that you're going to want to memorize? And we want to go up to a second degree. So you're going to write that in. Do you see the dot, dot, dots at the end of them? They technically go forever. We're just only going to take to the second power. So this will be 1 plus x plus 1/2 x squared. And I'm just going to stop there. 2 factorial is 2. So I just wrote a 2. This one we just did on the other side of the paper. It's geometric. A is 1 and R is X. It's this one right here, the very first one that we did. So you start with 1 and then you just keep multiplying by X. And again, it's dot, 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 but we're just only going up through the second power. We're going to multiply them together. We have e to the x, and then we have the 1 over 1 minus x. I just wrote them both out separately, and now we're going to multiply them together. Because we have these times together. No, I want to answer the question. Let me go all the way to the answer and see if it rings any bells from last time. What we're going to do is multiply these together, but again, you can't go above a second power. So I'm going to take this 1 and distribute it to everything. That'll just give us like that. And then I'm going to take the x and distribute it. But again, you can't go above a second power. Because again, technically these go on infinitely. It's dot, dot, dot forever and ever. You just have to cap it at a second degree. So if you take this x and distribute it, it'll be x plus x squared. And if you try to multiply there, you would get an x cubed. So you just don't want that one. And then we're going to take the 1/2 x squared and distribute it. But you don't get very far. You would distribute it to the 1. You would get 1/2 x squared. And if you try to go to the next one, you're above a second power. And then this, you're just going to put the like terms together. So you have an x squared, and a 1/2 x squared. What's that going to be? Yeah, good. Oh, you guys even said 5/2. 5/2 x squared. And then plus 2x plus 1. So this is your final answer to the whole thing. So it said we want a second degree. I'm going to recap to make sure and then if you still have a question, let me answer it. We wanted a second degree Maclaurin polynomial. I just separated this into the 2 separate parts. We have e to the x, and then we have 1 over 1 minus x, because this one is one that I'm kind of encouraging you to memorize. And then this one's geometric, so you can get it fairly easily. And then we just multiplied them together. We did do one like that last time. I think it was the very last one. Do you remember they give you a table for f and like all the numbers? You just took them and wrote them in there, and then we just multiplied them together.